you're working. Okay, welcome to the Year 11 PPE Paper 1. Just remember, you must show all stages of your working in order to get full marks. And you're reminded again right at the top of the paper here. Okay, question 1. Find the lowest common multiple of these two numbers. So we start with the 108 and we do a factor tree. Okay, so we split it into prime factors. 2 and 54. Okay, stop when we get to a prime number. 2 is another prime number, and 27. Okay, 27 goes to 3 and 9, which then goes to 3 and 3 here. Okay, easy to do. And we do the same for 120. Okay, and that gives us 2 and 60 and 30 and 2. Okay, and then we go to 15 and 2. And finally, we end up with 3 and 5. Okay, and we now put them into a Venn diagram in this way. So we take one ring to represent 108, the other one to represent 120. Okay, and we pair them off. The ones that pair off go into the middle. So if I start with the 2's, I've got a 2 there and a 2 there, so I can put a 2 in the middle. Okay, it happens again with 2 here and here. So the 2 goes in the middle again. Doesn't happen with any more 2's, but I do get a pair of 3's there and there. So I put a 3 in the middle. That gives me a total of 12 in the middle, okay, which is actually the same as the highest common factor. I'm just going to multiply those three together now. Now I look at what's left over, and I've got here, okay, another 3, but no 3 in here. So that 3 there belongs only to 108, and so does this 3 here. Okay, and I've got left over with the 120 a 2 and a 5. Okay, which just goes there and there. Now, if I multiply what I've got there with what's left over, I've got 12 there times 3 times 3. That's using these two here. 12 times 9, which is 108, and then I've got 2 times 5, which is 10, so 108 times 10, which is 1080, and that's the lowest common multiple. Next question. Okay, it says here you must show how you get your answer. So if you just write down the answer, you get no marks because you haven't shown how you got it. So you must show all the steps. 60 people in a choir, half of them are women. So 60 divided by 2 equals 30 women. Okay, next thing. The number of women is 3 times the number of men. So if I take 30 and divide it by 3, I get the number of men, which is 10 men. It then tells me the number of children to the number of men in the choir is n to 1, but it also tells me that the rest of the people in the choir are children. So if I've got 30 women and 10 men, and I've got 60 people altogether, then the number of children is 60 minus 30 minus 10, okay, and that gives me 20 children. Okay, the number of children to the number of men is n to 1. So the children to men is 20 to 10. That's the ratio using my numbers, which is the same as 2 to 1. So if we compare that with n to 1, then we know that n equals 2. Next question. A fraction multiplication. 1 3/4 is the same as 7/4. Okay, 4 times 1 is 4, plus 3 is 7. 7/4 times 4/3. Cancel out the 4's. They both divide by 4 to give us 1 and 1. The answer is 7/3, which is 2 whole ones and 1/3. Okay, simple question there. Next. This is a construction. I've done it here because I can't do this on the pen and tablet very easily. Basically, we've got to construct, and we've got to show our construction lines. So what we do here is we take the compass point at D, open the compasses up so the pencil is at P, and we make this line here. Okay. When we've finished and we've gone past the point where we think P is, below P, we pick the compass point up and put it on this crossing point here and make this arc around here. And when we've created this shape, we simply join the top of that to the bottom with a straight line and a ruler, and that's our line that we think would be, well, it will be at 90 degrees to the original line, okay, within the limits of the construction. Accuracy, okay, draw that line, joining those 2 points together, and there's our right angle there. Okay, next. Okay, this diagram, triangle ABC, the size of DCB to the size of ACD is 2 to 1. So basically, these two angles here are in the ratio to that angle there in yellow is twice the angle just next to it there. Okay, so let's put some working in to find the angle BDC, which is that one here. That's what we want to find. Okay, well, the first thing I'm going to do is take 75 and 51 from 180 to give me the whole of the angle at C. So 180 minus 75, that's 105. Take away the 51, okay, it's going to leave me with 54. Okay, so that's the angle in here. The total angle across here is 54, right? Now I need to divide that in the ratio 1 to 2 or 2 to 1, so I need to do 54 divided by 3, or 54 divided by 2 plus 1, okay, which is equal to 18. So 18 is one part, 2 lots of 18 will give me the other part, which is 36. Okay, so I've now divided this into a 36, and in here, in that part there, an 18. Okay, but the one I'm interested in is the 36, because if I now take 180, take 51 and 36 from that, it will leave me with what's left. So 180 take away 51, take away 36, leaves me with 93 degrees, which is the angle I need, which is the angle in here. Okay, next. Okay, this question is about the mean, and we've got to work it backwards. So we know that 4 red bricks have a mean of 5, so the total mass of the 4 red bricks must have been 4 times 5, which is 20. Okay, and the total mass of the blue bricks would have been, there was a total of 5 blue bricks with a mass of 9 each, so that would have been 45. I'll just put the totals there, 20, 45, and then we've just got 1 green brick which weighed 6. Okay, if we total those together, that gives us 6571. Okay, that's the total mass of all 10 of the bricks. Okay, now Donna says the mean weight of the 10 bricks is 7. Is she correct? Well, no, because 71 divided by 10 is 7.1. Okay, 7.1 kilograms. That's what the mean weight is. So what we need to say is no, okay, not correct. And just to finalize the answer, I'm going to say not correct because 7.1 is greater than 7. That's it. Next, simplify that, p to the power of 10. You multiply those two powers together. Okay, this one is best written like this: 12x 7y cubed over 6x cubed y, and then we just subtract powers when we divide. Okay, so first of all we've got 12 over 6, which is 2. We've got x7 over x cubed, which gives me x to the power 4. 7 take away 3, and y cubed over y is y squared. Okay, next. Okay, an accurate scale drawing shows the position of port P and lighthouse L. Now this is going to be difficult on the tablet because I don't have the original, it's not the same scale, but I'm going to show you how you would do it and explain the process. So the first thing is she sails from port P on a bearing of 70. So the first thing I must do, and I've already started it here, you can see, is measure a line with a bearing of 70 degrees and make it longer than I think I need. That angle there I measured is 70 degrees, okay, which is actually this angle in here. Okay, so it's clockwise from north. She sails for 1.5 hours at 12 kilometers an hour. So how far does she travel first of all? Well, 1.5 times 12 is 18 kilometers. And 18 kilometers, when I apply this scale, 4 kilometers to 1 centimeter, is 18 over 4 equals 4.5. Okay, so that's the distance on the diagram. So what I would do is I would get my ruler and I would measure 4.5 centimeters and put a little mark. Now it's about there somewhere, but you would have to measure it yourself on your diagram. 4.5 centimeters. Okay, and that's going to be the port Q. Now when I get to port Q, okay, and I now want to travel in a straight line from Q to the lighthouse L, which is there. And what's the distance of that? Well, if I measure it on this scale, it's about 5.5 centimeters. 5.5 times 4, using the scale conversion, gives me 22 kilometers. Okay, so that's the first answer, and the second answer is about the bearing of Q from the lighthouse. That means you're standing at the lighthouse and you want to turn clockwise, starting from north, that many degrees until you're facing Q. Well, it's nearly a full circle. Find this angle in here, okay, and that's about 35 degrees on my diagram, okay, and then I'm going to subtract that from 360 to give me the angle I need. So take away the 35 and that gives me 325, which is within the tolerance range of the answer. Okay, so that's the bearing. Okay, next question. Car travels for 18 minutes at an average speed of 72 kilometers an hour. How far will it travel in 18 minutes? Well, you see, the distance is speed times time, and 18 minutes is actually the same as 3/10 of an hour. Okay, that's useful because what I can do now is just take the 72 and multiply it by 3/10, and that gives me well, if I times it by 3, I get 216. So it's 216 over 10, okay, which is 21.6. And it's 21.6 kilometers. So that's the first part. Now in part B, we've got to evaluate this statement that David says that 72 kilometers per hour is faster than 20 meters per second. So we're going to start with 72 kilometers per hour. Okay, so 72 kilometers per hour, okay, is equal to 72, and then if we divide that by 60 and 60, in other words 3,600, that will turn it into kilometers per second. Okay, and what we now need to do is turn that into meters per second, and because there are 1,000 meters in a kilometer, we can say that that equals 72,000 meters, 72,000 over 3,600, and that's now in meters per second. Okay, and that simplifies because 72 divides exactly by 36 twice, and you can see if you cancel out some zeros that you're left with exactly 20 meters per second. Okay, so what we've done here is we've shown that David is not correct, so we need to say not correct, okay, because David was claiming that 72 kilometers per hour was faster, but we need to say not correct since 72 kilometers per hour is actually equal to 20 meters per second. And my working out above is the proof that I need. Okay, cumulative frequency. Okay, so plot the endpoints of the class interval. They've already done the cumulative frequency for us. We just got to put the points. So at 40, we plot 5, which is there, little cross there. Okay, at 60, we're plotting 25 up there. At 80, we're plotting 35, which is here, then 38 here, and finally 40 at the end. Okay, join them up with a smooth curve, or, as I'm going to do on this tablet device, a series of straight lines. Go back the same width as a standard class interval to 0 there, okay, and then from there a series of straight lines or a smooth curve. Either way, you must visit each of the points, okay, like that. Use your graph to find an estimate of the interquartile range. Well, there's 40, so the median is 20, the upper quartile is at 30. I'll do this in a different color. The upper quartile is at 30 and the lower quartile is at 10. So go to the graph and drop straight down, read off what you get. Go to the lower quartile, 10, hit the graph, drop down and read off what you get. Okay, and so looking at that, I've got 70 minus, that's about 44. So 70 minus 44, and that's the interquartile range. Okay, and that is 26. Okay, now we've got to find the probability that the person took between 50 and 90 minutes. So let's just find 50 and 90 minutes on the base of the graph. There's 50, okay, and project a line up from 50, hit the graph, and then project that across. You can see that's going to be at 30. Do the same at 90, okay, which is there, okay, and that hits the graph right up here, and then take that line across, Okay, and the difference between those two numbers is going to be, let's have a look, we've got 30, 35, 36 minus 15. So I'm just going to put that there, 36, take away 15, which is equal to 21. Okay, so that means there are 21 people between those two blue lines, and so the probability is 21 out of 40. Okay, and that's it. And it's 21 out of 40. Use your graph to find an estimate of the probability that this person took between 50 and 90 minutes. So that's the answer. Okay, and with probability you just leave it as a fraction. That's fine. There are P counters in a bag. 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag. 5 of those 30 are yellow. So this is a relative frequency problem. This proportion of yellow is 5/30ths, okay, which is 1/6. And you could simplify that and say it's 1/6. So basically we're saying that we believe 1/6 of the counters are yellow. So if we know that 12 of them are yellow, then we just got to say, well, if 12 of them are yellow, how many must have been in there to keep this fraction preserved? Well, it's 72, isn't it? So the answer is 72. Okay, and that's how you would do that question. Next. Okay, in this question, Spencer has made a mistake. He was trying to make Q the subject to the formula. So he started by timesing everything by 2, which is okay. I'm going to do the same thing. I'm going to put 2t, okay, equals, now it's going to be just Q, but it's also going to be plus 10, and he's put plus 5. So what mistake did he make? And I'm just going to say, he multiplied by, okay, that's what he did, multiplied by 2, but forgot 2 times 5. Okay, in other words, he forgot to multiply that 5 by 2 as well. Okay, there's various other ways you could put that, but that will answer the question. Okay, single fraction. So what I have to do here is find a common denominator, and the common denominator is x plus 1 times 3x. So I'm just going to write 3x, x plus 1 as a common denominator. Okay, and then above that I'm going to convert the numerators so they match. So basically I've multiplied the bottom by 3x, so I must multiply the top by 3x with the 5. So it's 5 lots of 3x. Okay, so 5 lots of 3x over 3x times x plus 1 is the same as that. And then on the other side with the 2, I've got to put an x plus 1. Okay, to make that have the same denominator. So when I cancel the x plus 1s, I'm left with 2 over 3x, you see. And then I just need to tidy all that up. Well, it's 15x plus 2x plus 1, sorry, plus 2, because I've got to multiply the 2 by each term in there. Underneath it's the same. Okay, you can multiply out the brackets. Tend to do that at the end because it might factorize, you see, beforehand. So keep it like that for the moment. And then I'm going to write that as 17x plus 2 over that. Well, there's no factorizing, so normally we multiply out the bracket. Okay, you don't have to do that. I think you can leave it as it is there, and it would be giving you full marks, but I'm going to put 3x squared plus 3x. Okay, so the denominator could be that or that. The numerator needs to be simplified as I've done here. Okay, now this is factorising, and what you've got to do here is recognise that x plus y is a common factor of both parts. So you've got x plus y times x plus y. Okay, I'll just write it out for you, but you've also got 3 lots of x plus y. So in total, you have x plus y as the common factor, and that's multiplied by x plus y plus the 3 from the other side, from the other part here, and that's it. Okay, it's only 1 mark, so that's it. Next, now we have a triangle. We're told that the area is 27.5. We've got to find what x is in order to find the length of the shortest side. So we know that a triangle area is a half of base times height. So that's the area of the triangle. Okay, so we know that that equals 27.5. If we double everything, we know that x plus 4 times x minus 2 must therefore equal 55. Okay, if we multiply out the brackets, we get x squared plus 2x minus 8 equals 55, and subtract 55 from both sides, we get x squared plus 2x minus 63 equals 0. Now we can factorise it. Okay, so we look for a pair of factors of minus 63 that add up to give us 2. Okay, and those factors are x plus 9 and x minus 7. Okay, and from that we can deduce that either x is minus 9, which is not possible because x is a length, or x equals 7, and that's the one we use. Okay, and therefore x minus 2, which is the shortest side, equals 5, and that's the answer. That's the shortest side. Okay, 5 centimeters. Okay, a proper algebraic question there, and that's what you need to do to get all the marks. Question 15. So we start by writing this recurring decimal, and we just call it x. 0.41818, etc. Okay, and then I normally just go through a process of multiplying each term by 10. So I'm looking then at 4.1818 and so on. And what you're looking for is the first time that the decimal part to the right of the decimal point matches. So then I get 41.818, etc. And one more time and I'll see a matching pair, and I'll show you that next, and that's 418.18 recurring. Okay, so what I can notice now is that these two parts, these two here, both have 0.181818 after the decimal point. So if I subtract them from each other, I'll lose the 0.1818 bit. So I get 1000x minus 10x, which is 990x, and that equals 418.18 minus 4.18, which is simply 414. And if that's true, then x must be the fraction 414 over 990. Okay, it doesn't ask for it in simplest form, it just says express it as a fraction. Well, we've just done it, so that's it. Next. Okay, rationalising the denominator, I just need to multiply this by root 11 over root 11. Okay, that will cause the denominator to now be 11. Okay, and the numerator is going to be 22 root 11. Okay, so that's now got a rational denominator, but it does say rationalise your denominator and give your answer in simplest form. So the 22 and the 11 cancel to give me 2 over 1. So it's simply 2 root 11 is the answer. Okay, so that's the first one. And this one is a bit more complicated. We have to find the conjugate of the denominator. So we need to write it as root 3 over 2 root 3 minus 1. Okay, but that has to be multiplied by 2 root 3 plus 1 over itself. Okay, so we take that and we times it by 2 root 3 plus 1 over 2 root 3 plus 1. And that will cause the denominator to become a rational number. Just might be helpful just to put some brackets around there. So we do a FOIL multiplication, first outer inner last, on the denominator. On the numerator we've just got root 3 times 2 root 3, that's 2 times 3, which is 6. We've also got plus 1 root 3, so that's the numerator sorted out. The denominator, well, we've got 2 root 3 times 2 root 3, which is 4 times 3, which is 12. Okay, now the inner and outer terms will cancel out, because you see here I've got 2 root 3 times 1, and here I've got 2 root 3 times minus 1. They cancel out, leaving me with just minus 1 times 1, which is minus 1. So if I simplify that, I've got 6 plus root 3, okay, over 11. And that's the answer. Okay. Tyler fills container A with water, and then she pours all the water into container B. She repeats it until container B is full of water. How many times does she have to do this? Well, this is about the volume, okay? But we're given the area scale factor. So what we do here is length, area, and volume scale factors. And we're told that the area in B is 9/4 of A. Of shape A. Okay, so that's the area, what we call the area scale factor. Now the length scale factor is the square root of that, which is 3 over 2. And the volume scale factor is that cubed, which is 27 over 8. So basically the volume of B is 27/8 of the volume of A. So basically, how many times does 8 go into 27? So, well, that goes 27 over 8 is 3 3/8. Okay. So that means that she's going to need 3 3/8 lots of container A to fill B. So she's going to need to do it 4 times. Okay. That's the answer there. Okay, next, functions. Now, what happens here is you're told that f of x means take x, cube it, times by 2, and then subtract 4. Okay, now this means the inverse function of x, f to the minus 1, is the inverse. So in other words, if we went backwards from an answer of 50, we would end up with x being 3. So all we need to do is put 3 in there, okay, which is in for x. So I'm going to do f of 3, okay, f of 3, and that equals 2 times 3 cubed minus 4. Okay, which is 2 times 27 minus 4. So I'll just put that in for full working. 2 times 27 minus 4, That's 54 minus 4, which is 50. Okay, so I have shown that f of 3 is 50, therefore the inverse function with 50 in will give us 3. Okay, and the second part is gx is that, hx is that, hg of x equals 3x squared plus x minus 1. Find the values of x for which that's true. Right, so what I'm going to do is, what is hg of x? So that was part A. Okay, this is part B. So hg of x means that you first of all apply a g, and then from the result of that you apply the function h. So a g is x plus 2, and then I've got to square it, which is what h tells me to do. So it's that. Okay, so now I know that x plus 2 all squared must equal 3x squared plus x minus 1. Okay, well, if I multiply that out, I get x squared plus 4x plus 4 equals 3x squared plus x minus 1. Okay, now I just need to move everything to one side. So if I take x squared from both sides, I get 2x squared. Subtract 4x from both sides, I get minus 3x. And then subtract 4 from both sides, I get minus 5. That's leaving me with 0 over here. Okay, that's a quadratic, and it factorizes into 2x, 5, and we've just got to put a plus or minus sign in there in a moment, and I think we will find that it will be minus 5 and plus 1. Okay, which means that the values of x are, from the first bracket, 5 over 2, or 2.5. Okay, and from the second bracket, negative 1. And they're the two values of x that solve that equation. Okay, next, this one's quite tricky. In order to do this, you've got to recognize that 9 and 27 are both powers of 3. Okay, and it works like this. The 9 is 3 squared, so it's 3 squared to the power of negative a half. Okay, and it's also equal to 3 cubed, that's 27, to the power of a quarter. Okay, and that's divided by 3 to the power of x plus 1. Okay, like that. Now, using the rules of indices, 2 times minus a half is minus 1. In fact, I'll just tidy these up first of all. So that's 3 to the power of minus 1 equals 3 to the power of 3/4, okay, divided by 3 to the power of x plus 1. Okay, and now I can remove the 3's, but recognize that I need to subtract the indices here on a division. So I get minus 1 is equal to 3/4, take away x plus 1, and that must be in a bracket. Okay, well, if I multiply everything by 4, minus 4 equals 3 minus 4 x plus 1. Multiply out those brackets, minus 4 equals 3 minus 4x minus 4. Add 4 to both sides. 0 equals 3 minus 4x. Take 4x from both sides. 4x equals 3, and therefore x must be 3/4. And that's the answer. Very difficult question, that one. And you need to know that 9 is 3 squared and 27 is 3 cubed. That's your starting point there. Okay, next, number 20. This is about transforming a function. Okay, this is the function f of x. It's got 4 sections. We're interested now in the function f of x plus 1 minus 3. Okay, this is a translation 1 place to the left and 3 places down. So every point on here moves 1 left and 3 down. Okay, so it goes like that. Let's use the straight line function there. Okay, so it's like that. Then we go down to there, like that. Then we go up to this point here. Okay, and then we go to there, like that. So I've taken that whole thing here, moved it along 3 and down, sorry, along 1 and down 3. Okay, that's the first part of the question. The second part says that I need to write down the coordinates of b after the graph of f of x, this one, is transformed to f of minus x. Basically, every x coordinate becomes its negative. So this point is reflected across the y-axis to this point here, okay, which is the point B. Okay, so it's flipped over the y-axis to this side and it becomes the point 2, 1. Okay. Next question, 21. Okay, a sketch of a graph showing this. I've actually done it here, as you can see. I'll just put that out the way for the moment, because the way that we would do this is a hand-drawn sketch. I'm using that because it's easier using this tablet and pen. But before I do that, I'm going to show you how we arrive at it. So this is a classic completing the square question. So I'm going to take out the factor of 2, and that leaves me with x squared minus 4x, okay, minus 5 over 2. Then I'm going to complete the square for what's inside the square bracket, okay, which is 2 lots of, now I halve the x coefficient and square it, okay, take away what's left over. Now that's going to give me x squared minus 4x plus 4, so I need to take away that 4, and then I need to also take away the 5 over 2. Okay, now when you process that further, you get 2 lots of x minus 2 squared, okay, minus that's 13 over 2. Okay, now that enables me now to see what the I'll do one more step to see what the minimum point is on the curve. That's equal to 2 lots of x minus 2 squared, okay, minus 13. So that tells me that the minimum point on the curve is when this is the turning point it's talking about here, happens at the point 2, negative 13. That's how you interpret that. So I'll need that piece of information in a minute. I'll just highlight it there. Now I'm going to solve the equation, and because I've already completed the square, I might as well do it that way. So I know that I need to set 2 lots of x minus 2 squared to equal 13. Okay, therefore x minus 2 squared equals 13 over 2. Okay, I need to square root both sides. X minus 2 equals the square root of 13 over 2. I now need to introduce the plus or minus because there are 2 possibilities there, and therefore x equals the 2 plus or minus the root of 13 over 2. Okay, so those are the 2 values of x where the graph would cross the axis. And the final thing I need to know is the y-intercept, which is where the graph would cross the y-axis, and that's simply when x is 0. Okay, and if we look at the original equation, that would be minus 5. Okay, so it crosses the y-axis at 0, negative 5. Okay, so I've got a sketch of a graph with a minimum point at 2, negative 13, crossing the y-axis at 0, negative 5, and these two values of x, 2 plus root 13 over 2 and 2 minus root 13 over 2, are where it crosses the axis. So I'm going to bring that in now, because to sketch it on here is really difficult on the tablet, but you would draw some axes, x and y axes like that, and you would mark those key points there. There's the minimum at 2, negative 13, and they're the two crossing points, which are 2 plus root 13 over 2 and 2 minus root 13 over 2. Just label them. I'll just put that in a different colour. So there's my 0, negative 5. Okay, there is my 2, negative 13. And it does say use the exact values. Well, this one here is going to be the 2 plus root 13 over 2, and the other one is the 2 minus root 13 over 2. So quite a lot of work to do on that question, but that would be a grade 9 question. Okay, I'm just going to write that square root again, so it's the full square root of both parts, the 13 and the 2, like that. Okay, and the next and final question. A lot to do here. I've already written this one out to save a bit of time, but basically I'm going to prove that two triangles are congruent. That means they're the same size and shape, they have the same angles. So what I have to do is use either side angle side, angle side angle, or side side side. I've chosen side angle side. What I've done is I've highlighted the two triangles I've got to compare, the green one and the yellow one, as shown here. I'm told that these are all 60 degrees because it's an equilateral triangle. Okay, and what I've done is I've used the fact that angles in the same segment are equal. So I can say that the angle ACB, that's this one here, is the same as the angle ADB, which is 60 degrees. Okay, that's what I've done up here. I can do the same for this angle here, angles in the same segment. Then I've used the fact that this and this are vertically opposite, and therefore that's 60 as well as that one. Okay, so I've explained all that here with the reasons. I've then looked at side lengths, and I've noticed that both the triangles I've got to compare have a common side of BC. Okay, so I've got a common side. I've got an angle here that's the same in both triangles. Okay, that one and that one. And now I can show another side being the same, because I know that if this is an equilateral triangle, that side length is equal to that one. Okay, and this side length is equal to that one. All right, so if I add D, E and EB together, it's the same length as AE plus EC. I've explained that here. So because I've shown that I've got a common side, another side of each triangle that's the same, and a common angle of 60 degrees in both triangles, an angle that's in that triangle there and this one here, I can now say that I've proved that ABC is congruent to DCB by the process of side angle side. Okay, quite a lot to write down there for 4 marks. last question on the paper, but that's one way of proving it as required. Okay, I hope that was all helpful. Take care.